Hey guys, welcome back to the channel. I have a 2002 Toyota RAV4 with a dreaded fault code P0758 Solenoid B. So this is a very common failure on these computers. I actually have repaired lots of them, but I have one returning. So I have actually one that is working properly, and the other one it has is right there. And I'm going to show you a test. All I do in these ones is powers and grounds and then power up. On Power Up, I usually put, I just substituted value, which is a test light, and then I put the multimeter so we can see the voltage. One thing that I'm going to do, actually, I'm going to set up a resistor so we can read around 5 ohms because that's what the computer is expecting to see. So give me 1 second. All right, again, just to keep the system safe, I'm also putting a resistor in place through the test light and then activation coming from the computer. These solenoid B, what the computer is looking for is in pins in the connector E4. You will have E4, E5, E6, E7, and E8. E4 is the one that has 22 pins. The rest don't have that many pins. Solenoid B, which is solenoid 2, will be in connector E4, pin 8, and pin 20, which is exactly what I am connected right now. So if you see, pin 8 will be here, and 20 will be like kind of like 8 is not the last one on the upper row, and then 20 the one before, and that is exactly where I am with those wires. So a regular reading with the car with ignition on, obviously, is very impossible to reproduce everything in the car in here. But what I'm looking for is at least the actuation. So if we turn this on, I'm going to turn the one on. So first, look at the test light. It comes on and it's dim because again the resistance. I want you to see the voltage around 7.4 volts. And I have that saved on a known good vehicle. So let me just show you those tests done in a car with no faults because I did the same test. So I'm going to just disregard the negative sign in there because I was in backwards on the leads. But yeah, we have, hopefully you guys can see, 7.7 volts, and that is in solenoid 1. Again, that will be solenoid 1. If we go back to that same folder that I have in here, solenoid 1 is in connector E4, 7, pin 7, and pin 9. So pin 7 right here and pin 9. So if we go back to that picture, we can see that I am in there in the E4 and 7, 1, which is 8, not used, and then 9. So this is for solenoid 1. And then we got 7.6 volts. On the solenoid B, we got 7.29 volts with ignition on. And this is what the computer is looking for. It reads that voltage transfer so as a resistance and amperage, and it says, okay, the solenoid is good or not. And then this is for solenoid B. We have pins 8 and 20. Again, pink and yellow with the black. And that is exactly how it's on the car. And we can see even those colors. If we go back to there, it shows the solenoid B as pink and yellow black, and then solenoid 1 as green with white and violet. All right, so and I can see also that on the color wire diagrams, it says green with a white and a violet on pin 7 and 9, and then pins 8 is pink and pin 20 is a yellow with a black. And that is the negative side of the solenoid. So we got all the information, everything as it should be. This is a known good computer. So now let's move. This is for Rafael here in Virginia. So I'm going to move his computer. I have marked his so we have uh, all those markings and everything, so I know exactly where to go. But yeah, it's pretty easy to decipher which connectors are. So let me move all this. Now we see what a good working computer does and see what this one will do. All right. All right, ready for the test. I forgot to show you grounds, connector E4 pins 21, 30, and 31, and connector E5 pins 1 and 8, powers. The only thing I need is E8 pins 1, 2, and 16, and I already spoke about the solenoids. All right, so this is now Rafael's computer connected. So let's power up right immediately. Oh, well, actually, it is coming on. Hmm. Okay. Now this is deceiving because it is working. So we got solenoid one working and it's being activated. I told him, this is I have repaired multiple of these computers and I have never have a return until his. This other computer he has is actually for a 4x4. Not sure why it's not set in a fault or if it needs to be driven. But I think he told me that he tried to drive it and it wasn't shifting properly, even though these computers are pretty much a match internally, right? The 4x4 has, its separate section, but the transmission, I think, are almost the same. But yeah, now we have an actuation of this solenoid. Hmm, this is now not what I expected to see. One more time, let me show you the voltage. And you can see it went to 7.4 for a brief of a second, same as in the other one. We can see that very nice and dim. All right, so one more time, and we can see the 7.4 volts in there. Let me go over to the other solenoid because sometimes this computer gives the wrong solenoid problem. And I have the value. So let me move this to solenoid A or solenoid 1. We are in solenoid B, so let me move that over. All right, move the cables. Now, as you see, they're in different positions. They're in pins, connector E4, pin 7, and pin 9. That will be for solenoid 1, right? All right, solenoid 1 right here, right? All right, so let's do the same test. Let's look at the light first, and it comes on. Hey guys, sorry for the interruption. Somebody called, I forgot to actually put the phone in airplane mode. But well, as you see, I have now a different setup on the bench. I actually connected both ECMs and I have the oscilloscope. So I got one channel onto the same pin on the known good computer, right? And on, let's say, known bad computer. Through a test line, through the resistors, everything in there will be exactly the same, and we will be able to see that. The thing is, well, right now I'm checking solenoid 1, so I'm in pins 7 and 9 and the connector E4. You see right here and right here, so these are where the solenoids are connected. And I don't see any difference. So these two computers, as far as there, and this is exactly, I wanted to start off with the known good solenoid and then check for the known bad solenoid. So I did see, well, I do see a little difference in here. Right here, you see that spot on the blue channel. So the blue channel is connected to Rafael. The red channel is connected to the known good computer. But actuation is there. So let me just zoom into this area where both are working and we can see that, and this is again whatever computer the strategy is, because the problem is with his computer, it has a hard fault that cannot be, he cannot get rid of. I say yes, I was able to reproduce, and I always do this test. I should have recorded, but since I have done multiple and it's so simple, there is multiple videos of how to repair these computers, and I have never fell on one. But yeah, so we can see that yes, we have a little bit of a difference on Rafael compared to this one, but is this because of the fault code? The amplitude of the activation and the start of the activation in both is exactly the same. So if I take the zoom out and we go to the start of the capture, which let's say the computer will try to actuate the solenoid and it will set up a fault depending on what it sees. But if it cannot actuate it, then we see a problem. Um, if we see here, it's pretty much a mirror. So this will be where the computer is doing its thing. You can see a click and then power on, on. And those are, I mean, a perfect image. Let me just interpose one on top of the other one, and then we'll see how now the red will kind of like stop or erase the blue channel. And we do have a little bit of a difference in here. Let me just zoom in this area. I'm going to move one channel down compared to the other one, but so we have one, the notch is a little different. You see what I mean in here? After here, it's pretty much the same. The notch on his, it's kind of like a power, the stop, and then goes up, and the no and good goes up, and then notches down. You see, that's the only difference I can see. But is that enough to condemn? That is where it's very, really hard to know. Why? Because we don't know what the manufacturer is doing in here, right? So all I can see is actuations, and they're both being actuated. All right, so let me move now the pins over to Solenoid B on both computers, and we will do the same test to see what we see. All right, be right back. Well, actually, I decided to, before I do that, because, you guys will taking my word in here, so I'm going to do the same thing. Right now, the scope is on. I'm going to actuate the both computers when this starts. So just waiting for that one to start, and we can see the same actuation in there and how it stops, and that's turning it off. So yes, I want to show you this live, so there is no misunderstanding or no thinking that I might be hiding something. So no, this is exactly, and we can see the same result, the same gap in here. Yeah, it is a little bit of a difference here. We have a little bit of a difference on the actual um, start as well, but the momentum, the amount of time that is trying to actuate it, they're both the same. All right, so let me move it over to, and this again on Rafael, we don't have a problem with solenoid one, and that's what I started with that one. So I cannot say that's bad because so we have a difference, and there is absolutely no fault. The only fault that he has is for solenoid B. All right, so let me stop this and see what we see on the other solenoid. All right, I switch the wires. So one thing that I want to mention, because it's very important to try to keep polarities the same, I move 7, which if we see here, this is a ground, so not a problem. So 7 is the positive side of the actuation. So I move 7 to 8 and then 9 to 20 to keep the polarities the same. So 7 is the orange wire. I've moved it from 7 to 8 and then 9 to pin 20. And I did the same thing in here. So we should have pretty much the same result. So let's see what we see on this on the oscilloscope. I'm going to save this capture, so give me 1 second. All right, so that is now saved. All right, so we're going to do the same. Computers are both off. And here we go. As soon as that starts the line. All right, so we got the same exact result. And I turn both computers off. So let me snap this off. And let's go back to the first capture. I did see a little bit of the difference on the end, but I mean, I don't see a problem here. I hope that you guys can see uh, that. I mean, I'm puzzled. I'm puzzled because, like I said, I have repaired multiple of these computers and I have never had a return. And now I have the problem with this computer, which what I repaired was actually solenoid B area and solenoid 1. I always resolder, this is a very common issue with these resistors and some of the resistors, like these big ones in here, these big ones in here, and so on. But um, with the test that I have and having this exact results, I'm not sure if I would even condemn the computer. I know that yes, we plug his computer on the car, and you can feel immediately the hard shift to reverse and the check engine light is on constantly. Um, in the other one, if we put this on his car, it will start because this is a 2002, so the immobilizer is in a separate system, not in the computer. You can start it in the computer, no check engine light, and it does shift at least from park to reverse with no hit, like you don't feel any hard shifting or anything. But he did mention that is not shifting properly when you drive the car, which I'm not sure why it will do that because pretty much same year model. And as you see here, they're pretty much almost the same computers except for the 4x4 part, right? But again, I'm puzzled here. All right, so let's try to analyze this a little bit. Let's see the amplitude, and we can see that both are pretty much the same. The only difference, as I mentioned, is this little part right here. So if we do a zoom in here, come on. All right, if we do a zoom in, why is not letting me do the zoom? I guess let me do it with the mouse. Oh, it's not selected. Now it is. So we see that little difference at the end, but that is, I don't will, I will not think that is a problem. I honestly don't see a computer shutting down a driver for and then doing that step for, I mean, we can measure that and you see what I'm talking about because if we measure the time, come on, if we measure the time from here to here, that is 16.25 milliseconds. So that is, it's just a super fast. Usually, when a computer is not happy about a driver or something like that, it will try multiple attempts until it shuts it down. But let's analyze the start of the signal. Now I'm trying to see if the drivers that control this, it has any problems. I can still see, and this is again the same difference that we had before, how the red, the blue goes high and then a little spike low. Let me do a little more zooming here so we can see this better. So this is where I am right now. So we have, as you see, how the blue, let me go back. I think that's too much of a zoom. Let me pick one, but go a little lower so we can see. No, this is still not good. Um, Trying to, get a whole picture of this, but if we put both at the same height, we can see the difference on height from activation to activation. If we go back to that, and this is, I'm not sure why I couldn't see that in there because I'm trying to pick up this. So let me go there. It shortens it down like right now a lot. The rest is pretty much the same. Let me put a cursor from here to here. So using the same channel, we will have 4 volts difference in there. So Rafael is going up to battery voltage. You see, this is something is being not completely shown. Let me take these rulers out because that's why I put the ruler because something is not being read properly when I'm doing the zoom. So let's do it like this. Let's keep it like this. Okay, so that's what I'm looking for. Okay, all right, so we are here. And at the same moment, this is in 10 volts, this is in 14 volts. After that, they pretty much mirror each other. You see what I mean? So, but right there, this one is not reaching that. So it's 14 to 10. We can see the same in here. And this is a spike. Take this rulers out. I'm going to go back and I'm going to select, well, we still got the zoom, like this area here. See, I don't know why it's doing that. So me sometimes don't want to work with you the tools. Yeah, right now I don't see the glitch that I was looking at. Well, right here, one, and it's not a glitch, it's actually the actuation. What I'm trying to show you is here, this, what, from the distance that we are, we see that as a glitch, but it's not a glitch, it's actually the activation, so it's going up and down. Again, I'm doing an analysis of these two signals to see if it's something that I can condemn, that I will say, okay, no, that one is not doing it, the other one is doing it. we can definitely see the high of the voltage from 14 to 12, and then after that this goes 10 to 14 almost. You see that's a little bit of a signature difference. We can see that in here as well, where this one goes up to, like, let's say, let's keep it like 10 to 14, right? So it goes 10, 14, and the other one is going 14, 12. So, will that be enough to condemn this? Is this what the computer is not liking? I'm gonna try to re reassess these also. These drivers in here and in here are part of the circuits, and these ones on the bottom. So I'm going to make sure that there is no broken solder joints in there, and then take it from there. But I hope that you guys like all this content and all these analysis that I'm trying to do to help a customer from, with a multimeter. You will never capture this. You will never be able to see this. This is why an oscilloscope is a tool when you have a problem like this. Because if, as we saw before, we are, seeing 10 volts and 10 volts and 10 volts, or 7 volts, sorry, never 14, right? Never, you don't see the actual signature of the activation. This is, again, oscilloscope is the only way to go. All right, guys, let me stop this. I'm going to use the microscope and see if I find something that it brings, that rings the bell. And if I do, I will correct and retry and see if that signature changes. All right, be right back. All right, guys, I decided to do another test. I'm keep trying to, get this puzzle solved or see what is going on. So right now, it's still connected on connector, sorry, on the pins 7 and 9. So just to remember what we are going through. So connector 7 and 9 is for solenoid 1, on connector 4, pin 7 and 9, right? So I have right now here, but I'm actually connecting a solenoid. This solenoid is like a 10 ohms, so it's a little different than the one is on the transmission, but that is a solenoid. So I have power and ground supplied by the computer. So we had a blue wire connected to one pin of the solenoid, and then the orange that I have channel blue of my oscilloscope, and then that solenoid. The test light is there, but it's not connected to anything. And this is the capture that I get. As we can see, the computer is in command and it can move that solenoid. I'm going to do it again on a capture. So we're going to see that happening. The other computers is still powering up. Nothing as far as a load into it. So we will see that on the red channel. So just disregard that one. I'm going to turn this off, wait for that to start right there. And we can hear the computer. I can see and I can hear the solenoid moving. So that is working. So let me stop that so we can go back to the capture. We can see that solenoid being activated, computers in control, and it can move it. So nothing wrong with solenoid 1. I'm going to move. I want to show you closely where I'm connected in pin 7 and 9. So I'm going to move it to 8 and 20. I'll be right back. All right. Okay, everything is now moved, and you can see now where my solenoid wires going through this solenoid are now connected to pins 8 and 20, which is for solenoid B, SL2. All right, so we're going to do the same test. I'm going to put the oscilloscope in the capture, or in the screen, sorry. I'm going to let it run freely and wait for the line to start. I just heard that solenoid working completely on and off, not a problem. So we can definitely see the actuation. Let me go back one more right there. And that is with a good solenoid install. I'm going to try to put that here. So hopefully we can see the pintle moving in there. Look at the capture in there, the pintle in there. Not sure if you can hear that. Trying to see where is that I need to see. Let me put my glasses. I'm gonna try to get you as close as I can because this camera is Sometimes when I'm using this recording, not the best, but I want you to see the movement in this section right there in between the pinto, right there. I'll try to get you to see. Hopefully you can see that one more time. And I can see the pinto moving. So the computer, and I'm in Rafael's computer, is working properly. And that is the capture right there. So I'm going to move it over to this one and see if we see something different. I'm going to save that capture to compare. All right, I save the capture. We will be seeing now the opposite. The lone activation on Rafael on the blue channel and the short activation on the red one because I'm now using the red channel for this computer. I move the wire so we are in the same solenoid B, and I move the connections in here to the yellow and the green, which is right here, right? Red, yellow, green, and we have the solenoid in there. All right, so let me run the scope and waiting for the scope to start right there. You can see now the red. Now we have a difference. Okay, now I like it. Look, red is still on. Now I got it. Ha ha ha. I got it. I got it, guys. This is exactly his problem. Oh, perfect. All right, so it definitely has a problem. All right, so because, I mean, we can see the actuation on the red channel is on. Is on, it's staying on, it's not going away. Look, all this time since it came on, I'm talking about three different full screens, which are 5 seconds per screen, but then on all the time. All right, so we narrow it down to being able to duplicate the issue. I'm so glad I thought about this because I'm like, yeah, I don't see any problems. I don't see any problems. Well, it is a problem. The driver comes on, but it goes off. So I'm going to move it back to his, and we're going to rerun this test again. All right, one more time. I move the solenoid, the positive side, onto this part, and then the negative side is on the blue channel, and sorry, on the blue wire. We have now the blue channel connected, so we should see the same if all is good. And that solenoid was always on, it stays on. All right, here we go, and we can see how it's disconnecting. It's not staying on. So this is the problem. 100% I'm reproducing it now. All right, guys, so let me see what I see, and at least now I am knowing exactly how to check this and solve this situation. So I'll be right back.